So first I had to remove the mbed LPC1768 board from the sockets in the application board, the green board, and place it into a breadboard. I then connected all of the required pins using jumper cables. I left out a few of the peripherals so I could connect the first piece of extra hardware, the Adafruit Ultimate GPS version 3, which is a small low-cost GPS receiver. Then during the development of the software, I ran into an issue of not being able to store enough map data, as this is an offline device. So I added the SparkFun Level Shifting MicroSD breakout board, which allows me to store mapping files on here, a microSD, instead of taking up valuable space on the mbed board. The peripherals which my project actually uses on the activity board are the N5110 display, the A, B and C buttons, and the joystick movements, along with the joystick button, i.e. the ability to click the joystick down. In order to fit all of this hardware on, I had to deviate from the original pin assignments of the activity board in certain cases to make SPI pins available for the SD card and serial pins available for the GPS module. The red items highlighted now are 3D printed brackets that were used in the filming of this video, more on that in the behind the scenes. The whole thing is then mounted to a small piece of MDF board to keep all the connections secure and make the device easier to carry around. For the vast majority of the remainder of the video, the format will be as follows. The forward-facing camera will be visible there, and the mbed activity board controls will be there. This is the first option on the main menu, and after the device has a GPS fix, it displays some useful information: the time, date, current location, and altitude, as you can see on the screen right now. The activity tracker is the fourth menu option. It loads up a map of your current location, and then when you click the C button, the activity tracker starts to generate the GPX file and writes the data to it on the SD card. You can then click C again to stop tracking, and that file can then be displayed on a GPS visualizer, like so. I've also done another short demo of this function with a small track segment across the beach. With the output file displayed like so. This is the third menu option, and it displays a small compass that, using the GPS data, orientates itself in the correct direction. I then walk in a square to demonstrate this. Walking north, it points north. I then turn to face west, and as you can see, west is now displayed at the top of the screen. I then turn and begin to walk south, with south now being displayed at the top of the screen. I then finally walk east to return to my original point, and the compass now has east at the top of the screen. The mapping function is option 2 on the menu, similar to the activity tracker, but this was developed first. It displays your location in the center of the screen with surrounding map, and then as you move, it updates your location. When you are close to the edge of the screen, you can click the A button to reload the screen with you in the center again. To exit this function or any of the others, you simply press the B button. So in order to shoot this video, I used a GoPro Hero 4 and my iPhone 7, both of which were mounted to the MDF board the device is mounted to, using custom designed 3D printed mounts designed in Fusion 360 and then 3D printed. Thanks for watching.